You are about to enter the invention dimension, a place where you discover and uncover and activate the skills within you that you need to be an inventor. Sit back and relax and get ready to enter the invention dimension. Welcome to another episode of Invention Dimension. As you are learning, there are different steps in the invention process, and following them help inventors like you arrive at the best prototype to solve their problem. After an inventor researches and tries different solutions and has decided which solution they want to develop further, they are ready to design a prototype. Today's episode is all about the design step in the invention process. When designing a prototype, an inventor thinks like and works like an engineer and a designer. In case you're not sure what kind of work engineers and designers do, let me explain. Designers create visual concepts by hand or using computer software to communicate ideas that inspire and inform the viewer. For an inventor, it is a drawing that lets people know how their prototype will look when it's built. Engineers produce specifications for the design, development, and manufacturing of something. They think about what materials or objects they will use to build the prototype, how big or small it will be, and the measurements or scale of the prototype. Engineers and designers both share what a prototype will look like through sketching and drawing. They think about how original the prototype design is compared to other inventions already in stores. There are lots of different ways to create a prototype design. You could use traditional drawing methods like pencil, ink, markers, or crayons on paper. Or an inventor might use computer drawing programs to create their designs. Let's go see how design impacts invention and products in our world. Come on, let's go.
What is this? Well, it's a lobster shell. Well, what's the function? So function is that bridge between the biology and the design. So they need to look about what the function is. So it's a home, it's a protection, it's flexible, yet it's rigid. So how can we learn from this shell to maybe make something that improves a jacket for the military, right? So I want them to actually look at each of these products and figure out, function-wise, how did this shell make itself? How was this made? It was made in water, using resources around it without waste.
I had to go through, find the research, find them, and then we took it to an engineer and said, hey, help me design the boards, the electronics to make this work.
I already had like an image in my head what I wanted it to look like, so we just went to the store, bought some teddy bears, some chairs, put them together. We're like, oh, this is too big for little kids, it's going to be too heavy, it's too small.
Sketching for the designer is the foreign language. It's the skill that we have that most other disciplines don't. It allows us to communicate with others a creative idea. Without the sketch, it's hard to get others to buy in. It's hard to get others to understand what the value of the creative idea is. So we teach our students again and again and again about the importance of sketching. They must learn how to sketch. They must know how to sketch rapidly. They must know how to use that as a tool to communicate with others a creative solution. Pieces of a good quality sketch include information that the designer can use to communicate their ideas to others, whether that be a manager or a client or a manufacturer. And those things include, it needs to have a sense of scale. In other words, am I designing a toaster that's this big or a toaster that's that big? And so putting a piece of toast or a glass of orange juice into the sketch helps establish a sense of scale. The sketch also needs to have a sense of context. Is this toaster housed in a kitchen or is it housed in a camper? And those may have two different approaches to the design. We try to get our students to draw in three-dimensional views, in perspective views, because while designers are trained to look at orthographics front, top, and right side and make the cognitive leap to what that will look like as a three-dimensional object is a refined skill, but most of their audience doesn't have that ability, so by drawing in perspective we give them a better sense and a better ability to understand the drawing. The drawing needs to have annotations that help us understand its features and functions. What will this toaster do? How do I interact with it? Where are the points of interaction that make something else happen? There needs to be a common approach to those drawings. In other words, if I'm working in a design house where 6 designers are working on the same problem, I want those drawings to look like they came from the same designer's desk. And so there's a common format to those drawings, so it's a consistent look for the office. It needs to have name, date, and concept number. Name and date are important to establish ownership to the designer. This is, about our intellectual property rights and assigning ownership to that creative idea. And then concept number helps me understand from a historical perspective, where did this concept come in the line of creations that we made for this project. We may get at some point in that design process where we go, that solution is good, but something's missing. We lost an element somewhere. We can go back in the history of how those were created to find where we went wrong and correct those mistakes.
Our students keep a journal and a workbook about their invention process, as well as document the process with photos.
That's awesome.
Why is that important?
It's important for a lot of reasons. It's important because you need to remember why you made some key decisions, especially if you need to explain your design or invention to someone else. But then it can also be important when it comes to the patenting process. If you, for some reason, you need to prove that it was your idea first and that it did not come from someone else, you can prove it with the date or just simply where you drew the inspiration from. So it's just really great that they document things because it's really important to do it.
We saw all the different kind of birds, mainly understand how they want to be comfortable, because they're going to be in these bogs through a long time or a short time depending on where their habitat is. So they need to be comfortable and they cannot carry the box apart. So it needs to be, even though it's cardboard, it needs to be sturdy somehow. So it was a lot of thinking about what was the best structural solution to make this happen.
Sketching and design process is a very important step when building a prototype, as it helps you see what your invention will look like. You'll know what size it has to be, what you have to add in there to make sure that everything looks just like your drawing. It really helps you to understand how it needs to be created.
Designing a prototype is an important step in the invention process. Inventors decide how a prototype will look and how it will be built in the design step. The more time they spend on design, the better they are able to build an actual prototype. The time you spend working on the size, materials, and the look of your invention will save you time when building it. You can see trouble with your idea in the drawing phase and discover problems you might have later when you draw it, and think with design in mind. Drawing and creating are fun work. You will be better prepared and work through ideas faster when drawing comes first. Remember, inventors use STEAM skills: science, technology, engineering, art, and math. Make sure you use the creative power within you and activate it. You will be a better inventor and problem solver when you really design and draw out your prototype.